Hi guys, my name is Mr. Lead, and today we're going to be looking at volcanoes and earthquakes. These are natural disasters that occur as a result of tectonic action. So, first one we're going to look at is volcanoes. Now, a volcano, I'm sure you all basically know what this is. It's a large mountain that releases lots of lava. But more than that, volcanoes don't just release lava. Sometimes they don't release any lava at all. Volcanoes might also release some of the following. They might release some gas, such as hydrogen sulfide, which is quite deadly. They might also release ash, which are found in the form of very, very fine rock particles that can just fill the skies and cause air traffic to be delayed for ages. But yeah, it can also release lava as well as just solid rock, such as scoria. Now, a key thing to know, if you're confused by what the difference between magma and lava is, it's just this. Magma is what you call lava when it's inside the earth. Lava is what you call magma when it comes out of the earth. So down here we have magma. And as this magma rises, it comes out and it's now known as lava. And this can be up to 1,200 degrees Celsius. So it's really hot stuff. Now, you're typically going to find volcanoes occurring at plate boundaries. And the reason for this is because if you look at a plate, and we're typically talking about converging plates, but it can be other types of plates. At a converging plate, one of these plates is subducting down. Now, this crust that gets subducted down then has to go somewhere. This crust ends up heating up to a really high point as it delves into the asthenosphere, and it ends up melting. And because it's not as dense as the rest of the stuff in the asthenosphere, it's not going to be able to drop right down and stay at the bottom of the asthenosphere. Instead, it melts and it has to rise up. So the reason we see volcanoes is because we have this subduction down here, and so the old crust gets heated up and melted, and that crust has to rise up and burst out of this crust up here. And so we form a volcano, and those volcanoes often cool down to form mountain ranges. Now, we don't just find volcanoes at subduction zones. In fact, sometimes we find what's called hotspot volcanoes. These are volcanoes that are found not on the edge of a tectonic plate, but maybe sometimes smack bang in the middle of it. You know, we have had, in the past, we have had some volcanoes in Australia, and these were at one point hotspot volcanoes as well. But one of the more famous hotspot volcanoes is Hawaii. Hawaii is not on the edge of any plate, except it's still really volcanic. And that's because the part of the plate that Hawaii sits on is a really fragmented part. It's a really soft part. It's soft enough that hot spots underneath are able to push their way up and through and form the islands that we see as Hawaii. So that's volcanoes. Earthquakes, on the other hand, are a little bit different. They usually happen not by subducting tectonic plates. Usually it's by transforming ones, but you can have it for all types of tectonic plates. Yeah, they happen because when you have two plates pushing in on each other or pushing against each other, there's a lot of friction that's holding them in place, stopping them from pushing against each other. And all of a sudden, after a lot of tension is built, that friction just suddenly gets released, and you get what's called a slip. The plates slip, and that sends shock waves throughout the Earth. And those shock waves are known as earthquakes. We can measure these shock waves with what's called a seismometer. A seismometer is basically, if you give me a moment, a seismometer basically works like this. You have a piece of pen, a pen or pencil, and it's put down, weighed down by, kept steady by a heavy weight. And it's down on a piece of paper. And this paper is constantly moving. And it's a really long piece of paper. So as long as the paper doesn't shift side by side, you're going to see the paper, the line on the paper to be straight. But as soon as you see, as soon as an earthquake occurs, that paper that's moving across gets shifted up and down a bit. And so you'll see, you'll see some waves being drawn onto the paper. So that's how old seismometers basically worked. Nowadays we have digital seismometers, which do pretty much the same thing, except are a bit more fancier. They don't need to use pen and paper now. But yeah, that's how a seismometer worked. I've now put a picture up here in the top right-hand corner showing what they look like. Seismometers recorded 3 different types of waves. The first type of wave is a primary wave, or P wave for short. These are longitudinal waves, and they're called primary waves because they're the first waves you see. Then the second type are secondary waves, or S waves, and these are transverse waves. They're the second types of waves you see. They travel slower than P waves. And then the last waves are surface waves, and these ones are the slowest. They're the last type you see, but they're the ones that are most destructive. So I'll show with a bit of an animation. First type of waves are P waves, or longitudinal waves. And a longitudinal wave will move back and forth. You'll see the particles moving back and forth, and they create this sort of action that you're seeing in front of you. These are the first types of waves that you will observe in an earthquake. So if you can imagine the Earth moving back and forth, or like the Earth underneath you moving back and forth like this, that's how it will first act in an earthquake. The second way it acts is with S waves, and these are transverse waves, which means that they move up and down. What's important to know with transverse waves, you're not seeing the particles, or you're not seeing bits of Earth moving sideways while going up and down. It's more like they're staying in the same spot horizontally, but they're moving up and down vertically. It's kind of like what you see when people are doing a Mexican wave. They're staying in the same spot, but they're moving up and down. So that's transverse waves. The thing with earthquakes and the thing with volcanoes is that we can't predict when an earthquake or volcano is going to happen. We can predict roughly where they're going to happen, but we can't predict when. And the reason for this is because it depends on the movement of magma, or it depends on the movement of magma deep in the asthenosphere, which is something we can't see or we can't really record. So we don't have any idea when a volcanic eruption will occur, nor do we have any idea when an earthquake will occur. The only way we know that an earthquake is going to happen is if we start seeing these P waves and then followed by these S waves, which are then followed by what are the most deadly type of waves, the surface waves. Surface waves look like this. Instead of just going up and down, they go up and down and side to side, because this is what happens when you see the shock waves interacting with the medium that is the air or the surface. And so you get what looks like this. They're going up and down and side to side. Remember, those particles aren't just moving up and down, they're moving back and forth as well. So these are the most deadly type of waves. These are what's caused the most destruction, and we only know when this destruction is going to occur about 5 or 10 minutes earlier when we see P waves and S waves. That's it. That's all. That's as early as we can predict an earthquake. Can predict where an earthquake will occur. If you look at where all past earthquakes have occurred, you'll see that they generally tend to occur along plate boundaries. Most notably, you'll see a lot more earthquakes occurring in these thicker areas. And that's because these ones are occurring on either converging or transform boundaries. And though converging boundaries have really deep and powerful earthquakes, transforming boundaries have very powerful earthquakes, but they're not as deep as converging boundaries. Whereas diverging boundaries like these ones, they're not as powerful. You don't see as many earthquakes occurring there. But yeah, that's how we know where earthquakes can occur, because we can see where past ones have occurred and where general hotspots and tectonic action usually occurs. Now, In terms of some other terminology around earthquakes, what you also need to know is the location of where the earthquake is called is the focus. But the place where you feel the location directly above the focus is called the epicenter. There was an image before that better shows this. Here we go. The focus is underground. The epicenter is the point above ground that you feel it. Also, the fault is what is a point that is usually where the earthquake occurs, or what happens as a result of an earthquake. It's basically just a crack in the earth. And earthquakes are also measured in severity with the Richter scale, a scale of 1 to 10, with 1 being a really weak earthquake, 2 is 10 times stronger than 1, 3 is 10 times stronger than 2, 4 is 10 times stronger than 3. So basically, you don't want to get anywhere near 5 or up. That's pretty dangerous. So yeah, in terms of here in Australia, we're pretty lucky. We live in the center of a plate, a tectonic plate, and we're on a continent, which means we don't get hotspots like Hawaii. So we haven't had as much tectonic history as, say, some other continents. But we have seen Australia move over time. Australia used to be a part of Pangaea, a supercontinent. Then Pangaea broke up to be Laurasia and Gondwana, and we were a part of Gondwana. And then Australia's over time been moving further and further apart. But because we haven't really seen Australia converging into any other plates since then. Hence, we see Australia to be a very flat continent. We haven't had much tectonic action to really form really high mountain ranges that we see, say, in Europe or in South America. And yeah, that is tectonic action. Thanks, guys.